per time, then we can have this expression. That is, the crash cost per period is equal to the crash cost. Crash cost means the cost when we are crashing the project, or the cost for crashing the project minus the normal cost of a project, divided by the normal time of a project minus crash time of a project. The second step is using current activity times. Find the critical path and identify the critical activities. As you know that we have already identified the critical path and critical path activities. The third step is focus on this third step. If there is only one critical path, then select the activity on this critical path that that can still be crashed, and the second is that has the smallest crash cost per period. Okay, so this is for if we have only one critical path, then we have to select that activity on the critical path that can still be crashed and that has the smallest crash cost per period. But if there is more than one critical path, then we will have to select one activity from each critical path that each selected activity can still be crashed. The total crash cost of all the selected activities is the smallest. Note that the same activity may be common to more than one critical path. Fourth step is update all the activity times. If the desired due date has been reached, stop. If not, you have to return to the second step again. As if you remember, in the project scheduling lecture, and especially in the topic critical path method, we have discussed an example, and that example consists of A, B, C, D, E, F, G, and H activities, and we have identified the critical path for that particular example. So we have identified the critical activities here. Okay, activity A is the critical activity, activity C is the critical activity, activity E, G, and H, these were the critical activities, if you remember. If you don't remember that, please go to the critical path method of our previous lecture. Okay. So this is the time, this is the normal time of activity A. For activity A, the normal time is 2. For activity B, the normal time is 3. For activity C, the normal time is 2 again, and so on for till activity H. But the crashing time for activity A is 1. The crashing time for activity B is 1. For C is 1, and so on for the other activities. Now let's talk about the normal and the crash cost. For example, if the normal cost of activity A is $22,000, if the normal cost for B is $30,000, and so on for the rest of the activities, then if we have the crash cost of activity A is 22,750, because we have to crash it. So if we are crashing the activity A, for example, its normal cost was 22,000. But if we want to crash this activity, or if we want to reduce the duration of this activity, then its cost will, its direct cost especially, will increase to 22,750. Similarly, the crash cost of the activity B will increase by $4,000 from $30,000 to $34,000, and so on. So we have to find out the crash cost per week. How to find out the crash cost per week? We have determined this value by applying this formula. Okay, that is the crash cost per period is the crash cost minus normal cost divided by normal time minus crash time. So the crash cost per week is equal to crash cost minus normal cost divided by normal time minus crash time, which is equal to 750. And similarly, we have applied this formula for all of these activities. So let's discuss the activity B. We would like to draw the project cost duration graph for activity B, for this activity B. So please focus on this activity. We are now discussing the crash and normal times and crash and normal cost for activity B. We discussed in the previous slide that the normal cost of activity B was 30,000 and its crash time is 1 and its normal time is 3. But if we look into the cost, the crash cost of the activity B, then its crash cost is $34,000. Okay, so this would be the graph that we can draw here. I think this graph is very simple. So crash cost per week, again, the 34,000 minus 30,000 divided by 34,000 actually the crash cost of activity B, and $30,000 is actually the normal cost for activity B, divided by the normal time, which is 3, and the crash time for activity B, which is 1. So 4,000 by 2 weeks, so it means $2,000 per week. I think I hope you understood this example. And this was the example we have discussed in the critical path and PERT methods. So this is the end of our lecture. I hope you understood this lecture and these topics, but if you have any problem with any of the topic or subtopic, you are feel free to contact me on my cell number or WhatsApp group or on my email. Till then, thank you and bye-bye.